Imagine hearing your favorite song without a speaker. Every beat, every voice, every emotion depends on a device hiding astonishing engineering. Most people see a simple box, but inside, dozens of precision parts transform invisible electrical signals into powerful moving air. And here's what nobody tells you. A single high-quality speaker begins its journey thousands of miles away inside mines and factories. Copper from Chile, rare earth minerals from China, aluminum from Australia, and advanced polymers meet inside one incredible factory. Think about this. Every speaker must move millions of times without tearing apart, yet remain unbelievably accurate. Some premium speaker cones travel nearly 20,000 kilometers before final assembly even begins. What happens next surprised even experienced engineers. Tiny imperfections smaller than a human hair can ruin perfect sound. Before music fills your room, every component survives fire, pressure, chemistry, precision machining, and relentless quality inspection. By the end of this journey, you'll never look at a speaker the same way again. Our journey begins with copper, the metal carrying every electrical signal inside nearly every loudspeaker ever manufactured. Chile produces nearly a quarter of the world's copper, supplying countless factories building millions of speakers every single year. After crushing and flotation, copper concentrate reaches roughly 25% purity before traveling toward giant smelters for refinement. Inside powerful furnaces exceeding 1,200 degrees Celsius, impurities separate while glowing copper becomes astonishingly pure. Refining raises purity beyond 99.9%, creating flawless wire ready for precision voice coils. But copper alone cannot create breathtaking sound. The real secret hides inside incredibly powerful permanent magnets. Next, we'll uncover how rare earth elements become the invisible force driving every heartbeat of a modern speaker. Rare earth magnets begin with minerals mined deep beneath China's Inner Mongolia, where enormous deposits power much of today's electronics industry. The ore contains neodymium, praseodymium, and tiny traces of dysprosium, elements separated through remarkably complex chemical refining processes. After purification above 99.5%, powdered metals become the foundation for incredibly powerful permanent speaker magnets. Hydraulic presses squeeze the powder under pressures exceeding 15,000 psi, creating dense blocks ready for high-temperature sintering. Inside furnaces reaching 1,080 degrees Celsius, microscopic particles fuse into magnets with astonishing magnetic strength. But magnets cannot move air alone. They need an incredibly light cone capable of vibrating thousands of times every second. Many high-performance cones begin as with pulp harvested from sustainably managed forests across Finland, Sweden, and Canada. Fresh timber enters giant chippers, where rotating blades reduce entire logs into uniform wood chips within just minutes. Those chips cook with water and carefully measured chemicals, separating natural cellulose fibers from lignin without damaging their remarkable strength. The finished pulp feels surprisingly soft, yet its microscopic fibers create cones that balance stiffness, weight, and natural acoustic warmth. Some luxury speakers replace paper with woven carbon fiber or Kevlar, materials famous for incredible strength and feather-light weight. These advanced materials cost several times more than paper, yet deliver exceptional stiffness that audiophiles instantly recognize. Most people never think about the glue, yet specialized adhesives quietly determine whether a speaker lasts decades or fails early. Engineers formulate flexible adhesives that survive freezing winters, scorching summers, humidity, vibration, and millions of powerful sound cycles. Before a single component reaches assembly, every shipment undergoes strict laboratory testing for purity, strength, moisture, and dimensional accuracy. Now, every ingredient finally stands ready. But transforming these raw materials into breathtaking sound demands astonishing precision beyond imagination. The real transformation begins now. Every raw material enters a synchronized production line, where precision leaves absolutely no room for mistakes. First comes a steel basket, stamped from cold-rolled steel under presses delivering nearly 200 tons of force in seconds. The press completes one basket every 3 seconds, while robotic arms immediately transfer each piece onto moving inspection conveyors. Next, precision CNC machines remove microscopic imperfections, spinning at 12,000 RPM to guarantee perfectly flat mounting surfaces. Most people never hear this sound, but the factory echoes with rhythmic presses, humming motors, and high-speed cutting tools. Meanwhile, copper wire thinner than a millimeter winds into voice coils with astonishing accuracy at nearly 800 RPM. Each winding layer must align perfectly. Even a tiny overlap could create distortion or unwanted heat during powerful playback. Engineers apply heat-resistant adhesive before curing each coil inside ovens reaching about 180 degrees Celsius for 30 minutes. As the adhesive hardens, the copper becomes permanently locked into a rigid cylinder ready for years of vibration. Now the magnets arrive. Automated presses position every magnetic ring with tolerances measured in only a few hundredths of a millimeter. Powerful magnetic fields demand careful handling. Specialized fixtures prevent magnets from snapping together with dangerous force. And this is where it gets truly extraordinary. Workers carefully center the voice coil inside an invisible magnetic gap barely half a millimeter wide. Imagine missing the center by the thickness of a sheet of paper. The finished speaker could buzz with every note. Next, precision dispensers apply adhesive beads only fractions of a millimeter thick before the cone finally meets the moving assembly. What happens next determines everything you hear. In the next stage, dozens of delicate parts become one perfectly synchronized loudspeaker. Now comes a moment every previous step prepared for. Separate components finally become a living, breathing loudspeaker assembly. First, the flexible spider centers the moving assembly, holding everything perfectly balanced while allowing thousands of rapid vibrations every second. Engineers measure every alignment within plus or minus 0.05 millimeters before the adhesive begins curing immediately. Next, the lightweight cone joins the voice coil, creating the moving surface that will eventually push sound through your room. Flexible rubber surrounds arrive next. Stretch it without tearing through millions of movements during years of demanding daily use. Specialized polyurethane adhesives cure between 20 and 40 minutes, forming flexible bonds that resist heat, vibration, and moisture. Most people never notice the dust cap, yet this tiny piece protects delicate moving parts from destructive contamination. Tiny braided tinsel leads connect the voice coil without restricting movement, surviving constant flexing throughout the speaker's lifetime. Automated soldering stations heat each connection to nearly 350 degrees Celsius, creating clean, reliable electrical joints within seconds. Every finished driver rests briefly while adhesives stabilize, preventing microscopic shifts before performance testing begins. Then engineers energize each voice coil for the very first time, checking smooth movement without rubbing or unwanted vibration. You can barely hear the quiet test tones, but sensitive instruments instantly detect vibrations beyond normal human hearing. What happens next surprised even experienced engineers. Every speaker now faces incredibly demanding quality inspections before earning final approval. This is where great speakers separate from ordinary ones. Every finished driver must prove itself before reaching your hands. High-resolution AI vision cameras inspect every surface, spotting scratches, glue defects, and alignment errors smaller than 1/10 of a millimeter. Within seconds, sophisticated software compares thousands of measurements against perfect digital models stored inside the factory control network. Most premium factories reject between 1% and 3% production, preventing even tiny imperfections from reaching customers. But appearance means almost nothing. The real challenge begins inside an acoustically isolated sound testing chamber built for absolute silence. Microphones measure frequencies from 20 Hz to 20,000 Hz, ensuring every tone stays balanced and remarkably accurate. Laser vibrometers detect cone movement without touching it, measuring vibrations with astonishing precision measured in microscopic distances. Engineers search relentlessly for distortion, unwanted resonance, buzzing sounds, and microscopic vibrations invisible to the human eye. Then comes endurance testing. Some speakers play continuously for more than 100 hours without stopping once. Climate chambers expose finished product to temperatures from -40 to 85 degrees Celsius, plus intense humidity and vibration. Robots perform every programmed inspection flawlessly, yet one critical decision still depends entirely on experienced human hearing. Some imperfections never appear on sensors, but trained ears immediately recognize the slightest imbalance in music or spoken voices. And this is where the story becomes even bigger. The speaker you see now is only one among billions produced worldwide. Every year, manufacturers produce well over 1 billion loudspeakers, powering everything from smartphones to stadium-sized concert systems. The global loudspeaker industry generates more than $60 billion annually, supporting hundreds of thousands of skilled workers worldwide. China leads global production, followed by Vietnam, Malaysia, Mexico, and Germany, each supplying specialized markets with remarkable efficiency. Did you know one premium concert speaker can move enough air to shake an entire arena with astonishing precision? Did you know the first commercial loudspeakers appeared more than 100 years ago, transforming entertainment forever? Did you know future speakers may use smarter materials, artificial intelligence, and advanced recycling to reduce waste while improving performance? The next time you hold one of these in your hands, remember, it didn't just appear, it was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us below. Tell us in the comments what product you'd like to explore next. Like this video and subscribe to the channel. We'll see you inside the next factory, where another ordinary object reveals an extraordinary story hidden beneath its surface.